Hello and welcome to the homework walkthrough for Lesson 2, Unit 2. Today we're going to be looking at 10 problems. The ready problems 3, 4, 7, 9, and 11 are all going to be handled very similarly, and they are going to be heavily reliant on understanding this standard form of the quadratic equation. So let's dive right in, starting with problem number 3. So here, remember, we're dealing with the standard form. So we have a is the term in front of the x squared, so a is going to be negative 2. B is the term in front of the x, so b is going to be 3. And what's not written here, and generally won't be, is that c is going to be 0, so it would be like plus 0. Number 4, once again, very similar to the problem that we just worked on. All right, the a is going to be the term that's in front of the x squared. All right, so a is pretty straightforward with the 6. B, this equation here can be written as 6x squared plus 0x minus 5. So b in this case would be 0 because it's not there. You wouldn't write 0x. You just leave it blank. And lastly, the c is going to be the standalone term, so that's going to be negative 5. Now I'll write this down here. Number 7 is a little bit more involved than in these first two problems, but still will require us to understand the standard form of the equation. So let's take a quick peek at number 7. So easiest way to go about doing this is to distribute this x through. All right, so we're just going to multiply the x through here, and we get x times x is x squared. X times negative 4 is negative 4x. So this is what we're left with when we distribute the x. So once again, a is going to be pretty easy to find here. Another thing that we'll notice that if there's no term written there, a is going to be 1. B, the term right in front of the x, so b is going to be negative 4. And c, once again, since there's nothing there, we could write plus 0, but we won't usually. I am for the purpose of this problem. But in general, if there's nothing there, then that value is a 0. Number 9, once again, this is a little bit more involved with the distribution. The numbers are a little bit higher. But we're going to handle this problem exactly the same way that we handled problem 7. So we're just going to distribute this 11. All right, and that is going to give me 11 times 3x squared is 33x squared. 11 times 5 is 55. So notice in this case we have no b term. So I could rewrite this if I wanted to. In general, I won't be doing this, but just to show this problem, I'm going to write in that term right there. All right, but just keep in mind, in general, no one would write this. So if you see, if there's a term that's missing there, that means that the b is going to be 0 in this case. So the equation, I'll rewrite it here a little bit clearer. So this is going to be 33, I'll just start with a y equals 33x squared plus 55. In this case, a is our 33. We already said that b is 0, and our c is a standalone 55. Number 11, same concept as number 9, but here we're going to distribute twice, or in two pieces here. So this first one becomes x squared minus 6x. And we're going to distribute the other side. So this is going to be minus 4x plus 4. So we rewrite this equation, y equals x squared minus 10x plus 4. And here it's actually one of the most straightforward problems we're working with. In this case, since there's nothing in front of that x, right, that's a 1, right? So if it were if there's no term there, it's a 0. If it's just the blank x, right, that value is a 1. So the A is a 1 here. B, -10, and C, 4. So that will take us through the ready problems. We're going to start to look at the set problems, and now we're going to be dealing with graphing quadratic equations. We're going to be tasked with a precise graph here rather than a sketch, and we're also going to include 5 points. So to start off, I'm going to draw a set of axes here, and let's see. We're not even doing. Yes, we are doing the right problem. Forgot to highlight the 13. So in this case, this is in a vertex form of a quadratic, and you'll generally see this as y equals ax minus h squared plus k, where the vertex is at hk. So in this case, if I were to look at this equation, all right, we have a it seems like we're missing the k. And in this case, we're going to treat that the same way that we did with the previous problem. If it's not there, we're just going to assume it's 0. So this actually gives us our vertex. Our vertex is at 1, 0. All right, so we take the vertex from this point and this point. 1, 0 puts us right here. We're being tasked with finding 5 points. Easiest way to do that. So we found the vertex. It doesn't look like there's going to be any other x-intercepts because the vertex is on the x-axis. So typically the x-intercepts are good points to find. The y-intercept is a good point to find. We can find that. And to find the remaining points, we can simply plug in values for x. So the y-intercept happens when x equals 0. So if I plug in 0 for x, we get y equals 0 minus 1 squared, which y would equal -1 squared. So that's going to be at 1. There's something called the point symmetric to the y-axis, or the y-intercept. And that point's going to be the same height, but on the opposite side of the vertex. And that point is going to be right there. So typically, if you were to have a graph with a vertex, 2 x-intercepts, a y-intercept, and a point symmetric to the y-intercept, that would be the 5 points that you're looking for. This case, since there's only 1 x-intercept, and the vertex is actually on the x-intercept, we actually need to find 2 more points. We can do that by just plugging in other numbers. If we were to plug in -2 for x, or sorry, -1 for x, we could get y equals -1 minus 1 squared. So that's going to be y equals -2 squared, so y equals 4. So we can find at y equals, at x equals -1, y is going to be equal to 4, so that's going to be right up there. And there's also going to be another point on the, so it's going to be symmetrical here, so there's going to be another point over there. So this is 5 points here if we don't get to use them all up for the vertex, the 2 x-intercepts, and the y-intercept and the point symmetric. We can kind of fill in the points this way. Oops. Sorry about that. This point is 1 up higher. There we go. And I'm just going to connect these dots here carefully. And this is what we have. So problem 15 is going to be a lot like this problem. And same thing with problem 17. And this will be the 3 set problems that we're going to be looking at for our homework assignment here. So let's jump ahead to problem 15. Right here we actually have an A value, which is going to change the shape of the graph. It's not going to change. It's still going to it's going to look similar, but at this one, since A is greater than 1, it's going to look a little bit more stretched out than usual. I'm going to rewrite the equation down here just so I don't have to keep scrolling back and forth. X minus 1 squared plus 1. All right. So for this problem, once again, first step is to draw in your axes. And once we have that, we can start with the vertex. And once again, the vertex is actually going to be embedded in this because we're in vertex form. So there's your H is 1 and your K is 1. So our vertex is at 1, 1. Plot the point. 1, 1. Okay, and it's going to be opening up because the 2 is positive, which means we have no x-intercepts here. So we're going to need to find the y-intercept and the point symmetric to the y-intercept. So let's go about finding the y-intercept. So the y-intercept we get when we plug in 0 for x. All right, so there's our 0 for x. So we get y equals 2 times negative 1 squared plus 1. Negative 1 squared is going to give us positive 1. So it's 2 times 1 plus 1, which is 3. So the y-intercept is at 0, 3. Plot that point right there. There's going to be a point symmetric to the y-intercept, and I will write this as PS, point symmetric. I didn't do this in the previous problem, but it's pretty good to have at least an idea of where some of your points are coming from. So the point symmetric is going to be on the opposite side of the vertex, so we're going to go from 0, 1, and this point is going to be here at 2, 3. All right, we can similarly find 2 more points the same way we did with the other one. We can set, okay, let's find x equals negative 1, and you can choose any point you want. I'm choosing x equals negative 1 because it's close to the other points. So we're going to plug it in. Y equals 2, negative 1 minus 1. So this is 2, and this is negative 2 squared plus 1. So this is 2 times 4 plus 1, which is going to give us 9. So this point here is at negative 1, 9. So there's 3, 6, just barely making it. And then there's going to be another point on the other side. Connect the dots to make our parabola, and there we have it. So just to be clear, right, the points that we're using for this one are our vertex at 1, 1. We get our y-intercept is at 0, 3. We get a point symmetric, so let's just say y-intercept. We get a point symmetric at 2, 3. And then we have just random points that we plugged in. We get negative 1, 9. And then on the opposite side, it's going to be 2, 9. Oh, I'm sorry, it's going to be 3, 9. All right. So, as I mentioned, 15 13 and 17 are all going to be very similar. And we're going to go ahead and do this process again for number 17. I rewrote this one again down near the axis so we don't have to keep scrolling back and forth. So let's take a couple seconds to look at this equation. So it's given to us in vertex form, right? We can look at it. We can immediately find that our vertex here is at -3 this time and -4. All right, so be careful, and this is going to be an ongoing thing to look at when you're doing these, is that we make sure we write in the h and k, or the x-coordinate and the y-coordinate parts of the vertex correctly. And that's something that we're going to need to look at as long as we're doing these problems. All right, so we have our vertex down. One thing to notice about this problem is that we have a vertex. It is going to be below the x-axis. And this is going to be a parabola that opens down. So we're at -3, -4. And it's opening down, which means that we're not going to have any x-intercepts in this case. And how we can tell that it's opening down is that we have this negative sign in front of the a value, which in this case is 1. So, easy point for us to find would be the y-intercept. We can find the point symmetric to the y-intercept. And then again, we can plug in 2 more points. It doesn't look like we're going to have a whole lot of space for this, but we can kind of sketch where they would be. So let's go ahead and find the y-intercept. So the y-intercept we get by plugging in 0 for x. So this is -0 plus 3. So this is going to be -3 squared minus 4. So this is going to be -9, because the negative's on the outside, minus 4, so we get -13. So I'm just going to sketch it in down here. So our y-intercept is at 0, -13. Now there's going to be a point symmetric to this point, and that symmetric point is going to be on the opposite side of the vertex and at the same y value. So see how this distance here is 3? There's going to be another point that has a distance of 3, and it's going to be the same y coordinate. So here, or right abouts, is going to be the point symmetric to the y-intercept. So as I sketch this in, it's going to look something like that. So there's your y-intercept, and your point symmetric to the y-intercept is going to be at -6, -13. So 3 points that we've already found. We get the vertex, we get the y-intercept, we get the point symmetric to the y-intercept. And we can do the same thing that we did to find the other points. All right, we can just choose random points that we want to use. Let's say if we want to say, let's say we choose -4. If we choose y equals -4, or sorry, x equals -4. All right, we get a negative y equals negative -4. All right. And plugging this in, we get, so this is going to be negative 1 squared. So we get negative 1 minus 4 is negative 5. So here we can kind of see that I didn't draw it perfectly to scale, but there we have it. There's going to be a point on the other side, so if I had chosen negative 2, right, this value would be over here at the same y value. So let me just fix this up and widen this out a little bit. And there you have it. So we've finished the set portion of the assignment. So the ready part was going through the equation in standard form. The set was in vertex form. And for the last two problems on the assignment, numbers 20 and 21, we're going to be looking at tables and seeing if we can identify certain things about the parabola or the quadratic equation looking at these tables. All right, so we have number 20 and number 21. The first thing we need to do is find out where the vertex is. And if there's one thing to think about, at least for these problems with the vertex, is that it's kind of a change in direction. So finding the vertex, right, we can see, okay, so we're dropping from 10 to 3, so we're going down, 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 and then right at this point, we start to go back up. All right, so if you look at the y values, right, this is decreasing to get to 3. We go down again, we go down again, we go down again, except for now, once we hit negative 6, we're going up to get to 5, and we're going up. Right, so this value right here is going to represent that change from going down to going up, and that is our vertex. So our vertex is at 0, negative 6. Line of symmetry or axis of symmetry, we covered this in the first homework lesson. The line of symmetry is going to be a vertical line, and it's going to be the exact same coordinate as our x value. So in our vertex, our x value is at 0, so our line of symmetry is going to be x equals 0. The x-intercepts. So looking at it, we have a parabola that can either have 0, 1, or 2 x-intercepts. So the number of x-intercepts is what we're looking at, not what they actually are, because we can't really tell what they are from the table alone, but the number of x-intercepts. So notice that we're going from a positive value here to a negative value, right? That means that somewhere in between these two, there's one x-intercept. I don't know what exactly it is for the x-coordinate. It's not going to be a whole number, obviously, but we're going from a positive value to a negative value, so somewhere across between those two y values and the x values of negative 3 and negative 2, somewhere along those lines there's going to be an x-intercept. Now what we can't see at the bottom of this table is that there's going to be another term here, and then eventually these numbers are going to start to get to be positive numbers. So once again, somewhere in here, we're going to switch from negative to positive, so there's going to be one x-intercept there. All right, I don't know what the actual values are, but you know that they are going to exist there because we're switching from a y value that is either negative or positive to a y value that's the opposite sign. So we're going from, in the top one, a positive y to a negative y, and the bottom one, we're going from a negative y to a positive y. So in this case, there are 2. And looking at, is our vertex going to be a minimum or a maximum? Well, look at it. If you see the table here, we have values 10, and then looks like we're going to the lowest possible value that we can find in this table is -6. So that means that this value is going to be a minimum. Last problem. We've reached the end. This is going to be very similar to the problem we just worked on. Find the vertex. Right, so we can find the vertex just as we did before. It's going to be kind of a change from whether the thing is going up to down or down to up here. So notice that these values are all decreasing. Oh, I guess that one's, I mean it is, but we can't see. So to get to 28, we're decreasing. To get to 13, decreasing. To get to 4, decreasing. We're decreasing here. And now to get from 1 to 4, we're going to make a change. And now this is going to be increasing. So we can find our vertex here as that one point where we start to change from increasing to decreasing or decreasing to increasing. All right, so our vertex is at 2, 1. Our line of symmetry, we've worked at this. It's going to be just the x-coordinate of the vertex, so x equals 2. In this case, the number of x-intercepts, so it seems like no matter what we do, there's not going to be any negative numbers here, right? So we're not switching from positive y to negative y, and it seems like there aren't going to be any x-intercepts because of it. So I'll answer part D first. This is going to be a minimum value, right? Because if you look at the table, that's the lowest value we got. And if the lowest value for y is 1, that means there's no point where the graph is going to have a y equal to 0. So there's going to be 0 x-intercepts for this problem. So this has been lesson 2 from unit 2, the homework walkthrough. Hopefully this was helpful. I'll see you with the next assignment.